quadrilateral ABCD satisfies angle ABC equals angle ACD equals 90 degrees, AC equals 20, and CD equals 30. Diagonals AC and BD intersect at point E, and AE equals 5. What is the area of quadrilateral ABCD? We have 5 options, A, B, C, D, E. So let's start by drawing out the graph. Okay, so quadrilateral ABCD satisfies the right angles. So let's draw the right angles first. So let's draw ABC. So let's just say this is B. Okay, so A, B, C. And then we know that ACD is 90. So we connect AC. And we want to draw ACD as 90. So something like this. And this is D. So CD is 30. And we connect AD to get the entire quadrilateral. Now we also know that AC is 20. And BD and BD and AC intersect at point E. And this is 5 and this is 15. Now this graph is clearly not accurate, but it's okay. We can use math to even out the inaccuracy in our graph. I mean, graphs are usually inaccurate anyways. So what is the area of quadrilateral ABCD? So the first thing you notice is that you can actually just figure out the area of triangle ACD. That's base times height over 2, which is just 300. Because 20 times 30 over 2 is just 30 times 10, which is 300. Okay. Now the hard part is just figuring out triangle ABC. What's the area of that? Intuitively, you want to find BC and AB and base times height over 2 because we have a right angle. Like, what's the point of a right angle if we can't use it, right? So you try to do so, but after a few tries, well, you realize that it's a pretty hard thing to do, to find AB and BC at the same time. Like, you want two sides, you've got no equations, no, I guess, extra information, no special properties, like, yeah. So, maybe we should try something else. Like, for example, we should try putting a circle around the graph, or something like that. So let's try to put a circle around the graph. Okay, so we try to put a circle around the graph. This is what happens. Now that doesn't look really helpful because this is not really a cyclic quadrilateral. What about if we put a circle around the the triangle? Now, not really helpful either. So maybe it's time we tried another approach, which is we know AC is 20. So if we let AC be the base, we can draw a height, AF. And all we have to do is figure out BF, which is way easier than figuring out two sides. Figuring out one side is often easier than two sides. So this is 5 minus x, and this is x. Okay, so EF is x, AF is 5 minus x. Now we just want to figure out BF, which I'll call h. So how do we do so then? Well, we can't exactly use circles, so maybe we should just use triangles. How do we use triangles? Well, are there any special properties? Not really. Like, they're just right angle triangles, no special stuff. Okay, so but we notice that these triangles, BFE and EDC, look very much similar because these two angles are equal and we have right angles. So actually they are similar. Not very much, they are similar. Triangle BFE is similar to triangle DCE via angle-angle similarity. Now, what does this tell us? Like, just having similar triangles won't really help much. But we know the ratio of two sides, DC and CE. That's 30 over 15, which is just 2 to 1. So basically, we know that the height is 2 times x, because x corresponds to EC, and the height corresponds to DC. So h equals 2x. Okay, so it's a bit helpful, I guess, but not that helpful because we don't know the majority of stuff we want to know yet. Okay, so so from here we're kind of stuck again. Like we're stuck again. Like, what's the point of knowing h equals 2x? Because now we can't really use anything. Like, okay, so we're gonna consider trying to list out equations to help us solve for x, because x is like the only variable we need. So if we solve x, we're done. Like, we're just done. So this is 2x. So maybe we can use like the Pythagorean theorem. But then, however, we don't know AB or BE to use the Pythagorean theorem. And we don't know BC either. But we can try and list out some equations. For example, we know that 2x squared or 4x squared plus x plus 15 squared is BC, right? And we know that BC, so this is BC squared. And we know that 5 minus x squared plus 4x squared, that is AB squared. So what does this give us then? So AB squared plus BC squared gives us AC squared. And we know AC is 400. So we have an equation. Okay, so pretty good actually. So we have ax squared plus x squared plus 30x plus 225 plus 25 minus 10x plus x squared. And that's 400. So basically we have 10x squared. So 10x squared plus 20x plus 250 equals 400. So let's move 400 over. We have 10x squared plus 20x minus 150 equals 0. So let's divide both sides of the equation by 10. We have x squared plus 2x minus 15 equals 0. So we can factor this out. This is just x minus 3 times x plus 5 equals 0. So x is either 3 or negative 5. Now in this case, x must be 3 because, well, we're talking about side lengths, and side lengths are not negative. So x must be 3. So since x is 3, the height 2x. So the height is 2x, which is just 6. So we know the answer is, so we know that the area of triangle ABC is base times height over 2, which is 20 times 6 over 2, which is 60. And when we also know that the area of ACD is 300, so the answer is 300 plus 60, which is 360. So that's our answer. Thanks for watching. Bye.